In the previous video, I mentioned that the trans and cis naming convention was not the official naming convention from the IUPAC. The reason for that is because it fails in more complex structures like this one here. Now, since I don't have the same thing on either side of this, I'm not really able to define this as being across or on the same side as something else. And so we have a different convention here. And this is going to be based on two German words, entgegen and zusammen. Now, we call this the EZ notation because of that. Zusammen means together, entgegen means opposite. So here, entgegen, opposite, and zusammen is together. So we can see these kind of have a similar meaning to the cis and the trans. However, we're going to be using these when we use a very specific convention for figuring out what's together, what's opposite. In order to do that, we need to label both sides of this double bond with something that's going to be the same. And the easiest way to do that is just by numbering them. So the first thing I need to do is remember that I've got this hidden hydrogen right here. And then in order to number these, in order to give these a numbering priority, I'm just going to look at their atomic numbers. So on either side of this double bond, I'm going to look at the atomic numbers of the atoms that are connected to these carbons. So remember, each of these is a carbon that is connected to the other carbon by a double bond and connected to a chlorine here and an oxygen here. The oxygen is connected to the hydrogen. So I'm not going to count the oxygen and the hydrogen. I'm just going to count the oxygen. So in order to create a priority, I'm going to figure out what are the atomic numbers for chlorine and oxygen. And I can just look at a periodic table for that. So chlorine is 17. 17. Oxygen is 8. Should know that off the top of my head. I don't. The higher number wins. So the higher number will be my priority 1. So let's put that in, let's give that a blue. So this is my first priority, this is my second priority. Okay? Now I'm going to do the same thing on the other side. Hydrogen is, of course, it has an atomic number of 1. Carbon is connected here to another carbon. So this would be carbon connected to 3 other hydrogens. Well, this carbon has an atomic number of 6, just like every other carbon. And so 6 beats 1, 6 is higher than 1, and so this is my priority 1, this is my priority 2. And so here I can see 1 and 1 are on opposite sides. And so this will get the entgegen nomenclature, which I just use an E. I just use an E for that. So let's name this compound. I have alcohol, chlorines, and I've got 1, 2, 3 carbons. So this will be 1 chloro. That'll be 3 is prop. My double bond is also on my 1, and my alcohol is on my 1. So 1 chloro, prop, 1, and 1 all. Mouthful. But I need to identify that it is entgegen instead of zusammen. So I'm going to write an E in parentheses, just like that. That's all I need to do for this. So let's look at some more complex examples to get a hold of this naming convention. In order to continue to flesh out this naming convention, let's take a look at 3 more molecules. I have the molecules already drawn up here, and I have the base name already figured out. So we don't need to take our time to do that. What we need to do is figure out, for each of these double bonds, will it be entgegen or zusammen? So for this first one, let's just take a gander. I've got molecules on either side. I'm going to compare these based on their atomic number. Nitrogen's atomic number is 7. This would be a carbon, which should have an atomic number of 6. 7 beats 6, so my priority is going to be nitrogen. 1, 2, just like that. Okay. On the other side, I have carbon again down here, that's 6, and the oxygen, which is 8. 8 beats 6, and so oxygen is the 1 priority, carbon is the 2 priority. And so my 1s are on the same side. That means they are together. This is zusammen. So I'll put a Z here just so I know that. But the way I'm going to write this into the name is just putting the Z in parentheses in front of it all. I don't need to do anything extra. There's only one double bond, so there's only one thing that Z can be referring to. Let's look at the next one. This one's a little bit different. Notice I've got a carbon here and a carbon here. Well, both of these have an atomic number of 6, so what do? There can't be a tie. So all I need to do is go to the next molecule out. If I have an identical atomic number, I'm going to look at the first point of difference here. So my first point of difference is this molecule right here. And what I'm going to do at that point is I'm going to look at all of the things that is connected to. So this is connected to an H, an H. This one is connected to 2 hydrogens and a carbon up this way. Once I've figured that out, I'm going to tally up all of their atomic numbers together, just like I would if I were playing a poker hand. I can win just by having a larger number of larger point value on my cards. So here I've got 2 hydrogens, each is 1, a carbon, that's 6. Then down here I've got 1, 1, and 1 for all the hydrogens. Well, 1, 1, and 6, that beats 1, 1, and 1. Okay. So then this gets the higher priority. So this is my 1, this is my 2. Right? Okay. Next one. On this side, I also have that same phenomenon going on. My first connection is an oxygen. Both the oxygens have an atomic number of 8. It doesn't really help me. So I need to look at what is the oxygen connected to. This oxygen is connected to a hydrogen, which has an atomic number of 1. This oxygen is connected to a carbon, which has an atomic number of 6. 6 beats 1. So I am 1, 2. So my 1s are on the same side. This is, once again, zusammen. This would be Z, 1 ethoxy, 2 ethyl, pent 1N, 1 all. Okay. Now for the last one. This is the first time that I have 2 double bonds. How do I label these? Well, first, just like before, I need to figure out, is this zusammen or is this entgegen? So I'm going to look at my functional groups here. I've just got a hidden hydrogen here, got a hidden hydrogen here. I'm going to compare my values. Hydrogen versus carbon is 1 versus 6. So this is my 1, this is my 2. Oxygen versus carbon, this is 6, this is 8. So this is my 1, this is my 2. So these are on opposite sides, so this is entgegen. Okay? Now here, same thing. Hydrogen is 1, carbon is 6. So my 1 is on the bottom, 2 is on top. And over here, oxygen is 8, carbon is 6. So I've got a 1 and a 2. So this one is zusammen. Okay, now that I've labeled that, I'm just going to do the same thing that I've done to label where my double bond is. I've got a 2 double bond and I've got a 7 double bond. Now I numbered starting from this carbon. This is my 1, 2, 3, 4, 5, 6, convenient, 7, 8, and 9 carbon. Okay? So my Z is at my 2 carbon. My E is at my 7 carbon. So I'm just going to write this in. I've got 2Z and 7E. So 2Z, 7E, non-2,7-diene-2,7-diol. There we go. Okay, lastly, let's look at two more examples, one being a little more challenging with similar carbons stretched out, and we really have to chase it down, and then one exception. So first, this guy. If I'm looking at which side is going to be which side of this double bond is going to be my first priority and which is going to be my second priority, I need to find my first point of difference between these two chains. So here's my first carbon, okay? Everything's the same. Second carbon, slightly different. This carbon connects over to another carbon. This one connects to a nitrogen. So when I hit this carbon, this one right here, I need to figure out what are the things that is attached to. So over here, it's attached to a nitrogen. So let's just bring this down. It's got a nitrogen. It's got a hydrogen and another hydrogen here. So NHH. And this one is going to have a hydrogen, hydrogen, and a carbon. Okay. If I bring that out, then it's going to be CHH. This is 6, 1, and 1. This is 7, 1, and 1. That wins the priority. And so this is 1, this is 2. Okay? But what if I change this just a little bit? What if I adjust this so that instead of connecting to one carbon, this actually connects to 2 carbons? Let's take a look at that. So I've just swapped out a hydrogen for a methyl, right? But I'm still looking at the same carbon. This is going to be the same point of difference, right? The second carbon out, this one versus this one. Well, now instead of being carbon, hydrogen, hydrogen, this is carbon, hydrogen, and carbon. C, C, H. Well, this would be 6, 6, and 1. Well, now my total here would be 13. My total here is only 9. So now this carbon would win. So it's very important to be able to recognize what are all of the things that that is attached to, not just what has a higher priority. We need to make sure we're keeping in mind all of the different attachments those carbons have. So now let's switch our numbers because now this guy wins. So this one is now number 1, and this one is number 2. And we'll do the same thing on the other side. Where's my first point of difference? Well, first carbon out, they're identical. Second carbon out, identical. Third carbon out. Now we're going to have a point of difference. I've got an oxygen versus another carbon. So I don't even hit my fluorine. So here, this is my carbon that I'm looking at, right? So the 1, 2, third carbon out. So this one is connected to an oxygen, hydrogen, hydrogen. It's OH. This one, this is a carbon right here. It's connected to a carbon. Even though there's a fluorine right here, even though fluorine would beat oxygen, I haven't hit it yet. This is carbon, hydrogen, hydrogen. OHH beats CHH. So my priority is 1 and 2. Well, with that priority, my 1s are on opposite sides, and that would be antigagen. All right, good enough. Let's look at this one. What do you see about this? If I map out this side, yeah, this is carbon versus oxygen. Okay, yep. This is going to be priority 1, priority 2. What about this side? Well, they're identical at first, right? So carbon 1 is identical. Carbon 2, that's also identical. And then I get all the way out to my third carbon, and it's still identical. So what would have the higher priority? Well, in point of fact, neither. Because this molecule, I could switch these back and forth, and I would have the same molecule. It would not change the structure, it would not change the function, it would not change the isomer. So this, because both of these sides are the same, is not a geometric isomer. It is not a diastereomer, and it does not get that EZ naming convention. So we need to keep that in mind. The only time we're going to use Entgegen and Zusammen is when we have two sides that are completely different. Okay? If we have identical molecules, it is not different. We do not use the EZ notation.